Okay, I can go. So thank you very much for coming, guys. Let me welcome you at our session. It's 20-minute session, so it's very brief, very fast, very short. So hopefully you will become data testers by the end of the session. This is actually, just to be transparent, a product session, obviously. Is here anybody who would know what the product name is? You know what? Cat, yes. Thank you very much. Here are the socks with cat. You might have some already, no worries. So this is actually what we want to show you, actually, how you can test data efficiently. So you are maybe brave, but not that much. Actually, I am here with Peter, my colleague. We have been spending 15 plus years in data development, data solutions development, data warehousing, Microsoft platforms, Azure, blah, blah. And this is kind of a product spin-off, which is focused on data quality, because during that time we developed and very much played with this product, which we now actually will be presenting to you. Why? This is the why. Because what we do actually causes that actually billions of dollars all over the planet is wasted, because a lot of business people actually do decisions on top of data. They are either wrong and they don't know, they are incomplete, they don't know, they are just kind of maybe useless and they don't know. But actually they would like to know, but for them it's always tough to go into the data quality because they think it's expensive and complex. Billions of dollars is also wasted because not every data solution or not all investments you guys are part of actually even reach production. We've been to many projects actually, or seen many development teams who actually wanted to be productive, but they didn't get trust. The solution actually wasn't providing the results. Actually, the business would trust it that much that they would really put it into production. So the general number is that, again, billions of dollars is wasted because we do not trust what we actually have been or are developing. And it's kind of, again, tough to get the feedback and reach the trust. So in general, the whole idea is that data are beautiful, they all matters, but until we really trust that we are looking at the proper data, it's useless. It's just, again, waste. And what are the typical automated data testing obstacles? So actually, how to tackle that? So what's the problem? Why we don't do it, actually? And the major answer is complexity, or we think it's complex. It's complicated, maybe expensive. So the problem's complexity is time. We don't have a time to test because it's complicated. We don't want to invest even time to, because again, it's money. Resources, we do not have people actually who would have the know-how. How? So that means non-existing practices. Okay, so maybe we have a time, maybe we have resources, but how the heck we should test the data? What's actually the best pattern? Should we do big, complex test cases? What tools we should use? What technologies we should use? Is it actually something that would really, like one tool, help to my team with everything? So actually the tool set is missing completely. There are no tool sets which would be easy for people that would have a proper know-how, and it would be somehow covered by some practices which can actually be proven, which we may say about that we would like to use them. So it needs to be simple. And actually Peter will show us right now how simple can look like in the case of cat. So Peter.
Okay, thank you. So, give me a second. So let's imagine that I'm a junior data engineer who was tasked to create simple data dimension. Everybody did it at least once, I guess. Everybody who deals with data created something like that. So it has some date, year, name of month, name of day, things like that. So when I'm done with the development, I need to check what I developed. This is easy example, but still useful. I would check lots of things, actually. I will show only one example. This date dimension has to start somewhere at some date, and it has to end at some date. This is the decision you have to make somehow. So it may be based on some dates in some staging table, for example, or beginning of the dimension may be date when the company started, and end maybe end of next year because of budget, for example. But you always can express this expectation, like when it can start and when it should end, the dimension with simple SQL statement, something like this. And then there is reality. I finished the development, the date dimension is ready, and I have some dates. So what I do in this example, I run both of these, and sorry, it's not visible. Yeah, and I compare the dates. So I use my eyes as comparison tool. I look left, right, and I can check whether my expectation is met or not. That's not a problem to use eyes as comparison tool, but I see two problems here. First is my expectation is not met because the end of the dimension is at the end of this year, and it was expected at the end of next year. So I need to run the test again until I verify that my expectation is met. So I need to repair my code or do things like that. Second thing is even if my expectation was met, then the system goes to production someday. It happens sometimes that what we develop really hits the production and people use it. And how do operations know in 1 year time, for example, that in December that the dimension has correct dates for next year, for example. So both of these problems mean that we should automate the test. So if I automate it, I can run it anytime, and anytime there is a problem with my data, it does not meet my expectations, then the test fails, and we know about the problem. We use cat for this, as Thomas mentioned. Installation of cat is a one-line command, so it's only this line of code that you can grab from documentation. It's PowerShell module, so you only use install module cat, and that's it. You have it. I already have it installed, so it takes a few seconds. But even if you don't have it, it's 15 seconds to get that module. Then I import module cat. And then I need to prepare my tests. We have a template for that, so with one command you can also generate the template. And you need to define only data source. If you have more data sources, you can define more. Here I only say that friendly name for my data source is DWH. It's SQL Server, and I put connection string. And then I only grab the SQL statements I already have because I tested them. So even if I do manual testing, I do some testing, so I can just grab the queries and automate them within seconds, just copy paste, and I give it some friendly name. Dim dates has correct dates. That's it. And I run it with single command, invoke cat project. And I should see that my test failed because the expectation is not met, and I should get some friendly message that expected end was different than actual value in dates dimension. So this way, within a few clicks or a few commands, I automated tests for my data. This is a relatively simple example. Let's say we have something more difficult to do. Let's say I have some database with data about some airport. I have some source system. It's in Postgres. I have some DWH. It's in SQL Server. And then I have some reporting in Power BI, and I need to verify that data are the same in all of them. Because I, for example, load the data in an incremental way, and there is lots of problem. There is lots of room for problems actually, because my incremental code may have some bugs. And or for example, nobody notices in July 2nd on Sunday that the process that should run actually didn't run, and we are missing some data. So I will open the other example. It's this one. Here I already have to define 3 data sources. One is for Postgres, again, name, friendly name, what it is, connection string. The same for SQL Server. And the third one is a connection to data in Power BI semantic model in Power BI workspace. Here we use service principal and secret and stuff, but it's relatively easy to set up. And my code looks like this. I have two tests. First, check the Postgres database against SQL Server, and I group dates of flights. I count numbers for the date, and I compare the same stuff against SQL Server against DWH. And if I'm missing some data, because for example some process that should have run didn't run, I immediately know what date is missing and that I have some problem. And the same I can run against Power BI Workspace, against semantic model. So here I compare SQL Server with DAX that I run against the dataset. Here I have to use just because Power BI doesn't understand SQL statements. And that's it. I will just again import module cat. Invoke cat project. It will run a bit longer because here I already have tens of thousands of rows, but it still should be relatively quick. And now I know that all the data in Postgres and in SQL Server and in Power BI semantic model are completely the same, and I have I'm not missing any data.
Thanks, Peter.
Mm-hmm.
It's so simple that you may say it's stupid, but that's actually our intention. So everybody can do that. Mm-hmm. Everybody can write SQL statements which can be compared, and our tool is only just to wrapping it up. So you cannot anymore actually complain, there is no tool set, it's too complicated, we don't do it because we don't have a time. We all produce during data development queries, and if there is any query which is kinda putable there, or I can put it there and just say, okay, is it still returning what I always expected to be returned? It can be part of your test case or test suite. The output of the query can actually be in standardized form, so later you can push it towards Azure DevOps. Peter wanted to show that as well.
Yeah. Sorry. Actually, because it's implemented as PowerShell, it's very easy to implement it into any platform like Azure DevOps, GitHub Actions, GitLab, Jenkins, and any other. And it's about running those three commands. So the definition of the pipeline is really like run import, install module cat, import module cat, invoke cat project, and that's it, and publish test results. And then in Azure DevOps, it has a very nice feature like for displaying test results. So I can click some failed test, for example, and see what test failed. Here we have, for example, a check that any ticket cannot have price bigger than 50,000 Czech crowns. If we have the data that broke the rule, and we have the SQL statement that we defined that we use to define the rule. So I can grab it, go to management studio and troubleshoot. How is it possible that I didn't expect something to appear in the data and it is there, and check what's the problem.
Actually, this Azure DevOps feature, I don't know whether you ever use it, but this is built in. This is not our stuff. We just pushed the output of the cat into the Azure DevOps, and this is all built in. So again, your team, if for instance you are using Azure DevOps, you can use it again more or less immediately. Thanks, Peter. Could you please switch it back to the presentation? Sure. So it's so simple that you may ask, okay, how can I combine it for my use case? It's then your task to do. Actually, you can combine whatever queries you like to, whatever data source you'd like to, because there are more to come, There are more features actually in the tool which we cannot show you in 20 minutes demo, but actually you can practically connect to any data sources which you have a connection, which you can assemble connection string for. You can generate tests even from metadata, so it's not only that you need to write the SQL code by yourself, but there is also support for templating. You can even load the test definitions from any source, so it doesn't have to be in YAML, it can be in Excel, it can be generated from stored procedure. We already said that you can export the output to standardized format, like JSON, MSC, and JSON, etc., but you can also store the output into the database. We are asked by our clients to have such a feature, and it's also you can parallelize this. We actually support all the data sources, like we said, Fabric, Postgres, Databricks, Accessible, Dataverse, etc. So if you may go one more, We have a Kit Studio, which is somehow
there
corrupted.
is a bug.
It's a SVG shown in a PowerPoint problem, sorry. But we have also a UI application, because we are again pushed by our clients, which are among you guys, somewhere sitting. Thanks, Damien. So we have also, this is brand new, actually community preview version in Microsoft Store. You can find Kit Studio, which is actually just showing what the test and how the tests look like, and you can debug them and actually onboard also business people to the game. Because one thing is that if it's simple, junior people or rookie people can really use it and help you, so they are actually then also cheaper, so you don't need to waste time of data engineers who you want to actually build up the solutions and who are usually more expensive. On the other side, there is business. So business also is keen to help you with, for instance, UAT testing, because they are knowing how to write a SQL statement. They know it perfectly. They know perfectly what the pivot table usually is about. So actually they can contribute to put some SQL statements into whatever YAML or Excel file as well. So suddenly you see that there are many, many use cases actually you can utilize in your environment. Just briefly, the typical scenario where you can apply, then again, you can imagine there are a lot of them, is either data quality. So the select can be put on top of your data. So are there, I don't know, dates, flights in my system like you would expect? Are they actually equal between the layers like staging, landing, reporting stuff? But also you can focus on the data architecture. You know that schema or everything what's technical is still data. So you can question the same data as well. Do all, for instance, SQL procedures following the same naming pattern like we agreed on some architectural meeting? That's one simple query, actually. And you can have it there forever. So once you add it, it's there. Data access, again, this I would skip because it's complicated to describe, but again, you can generate a lot of tests automatically. Data migration is a perfect example. Again, you have an old system and you have a new system. Do the data match? Again, it's a query. You know, you can look to the left, to the right, like Peter was showing previously, and you can just say, okay, the old system looks like that, the new system looks like that. And if you redeploy the new system, you can again run it automatically. So you do not need to ask other people from business departments, please, could you compare the new system with the old system just on Friday afternoon when you have real time to do that. So again, the productivity is then brutal. And data consistency, this is more about the reconciliation. So again, like last major use case we usually apply it to is that in production, you can easily run those tests as well because it's just a select. It's not invasive. Naturally, you cannot send towards your production all the queries or 100,000 queries every minute. That would not be probably the best case. But still, the data consistency you can check every night. Are the data in system like SAP or accounting system consistent with my reporting platform layer? Also, again, you can automate it, you can put it there and have it forever kept by automats and not people. If you'd like to give us a feedback, thanks a lot for coming. Feedback is on the QR code. Actually, I was told that every feedback or every question, every feedback is actually processed like a donation towards some charity, so please provide us a feedback. It was very quick, very brief, but we've shown you actually the essence of what the cat about is, what is cat about. Yeah, it's super simple, super stupid. Just use it. Okay, thank you very much for coming, guys, and see you later.
Thank you.
Bye-bye. Thanks, Peter.